Okay, guys, this is question number 2 from the May 2019, okay, AS Pure Maths paper, okay, from the Edexcel series. Okay, so this question, okay, is question number 2, and it's from the Edexcel AS Pure Maths Edexcel specification, okay, for AS students, okay, so students that are in year 12, okay, but it's also appropriate for year 13 students as well. Okay, question number 2. Find using algebra all the real solutions to the equation 16a squared is equal to 2 root a. Well, if I square both sides, okay, because I don't want the square root here. So if I square both sides, I'm going to have 16a squared, all squared, guys, okay, so all squared. And if I square the right hand side, I'm going to have 2 root a, all squared, okay. Now what's going to happen here is I will not have this square root here. So by squaring it, so 16 squared is 256. I'm going to have a to the power of 4. So I multiply the indices, okay, when it's in a bracket. So 2 times 2 is equal to 4. And that's equal to, well, 2 squared is equal to 4. And root a all squared just goes to a, guys, okay. So that's my equation. Now bringing the 4a over to the left hand side, I get 256a to the power of 4 minus 4a is equal to 0, okay? So we have like a quartic equation. Now factorizing it, so taking out the biggest common factor, well, I'm going to have 4a here, and then in brackets, I'm going to have something, okay, times a cubed. Okay, and then take away the 1, brackets closed, is equal to 0. So 256, guys, divided by 4, sorry. So again, I can just do it on my calculator or a bus stop method to the side. Okay, remember the A-level maths calculators are allowed, guys. Okay, I'm just doing it to try to show my full workings. 4 into 2 goes 0, with 2 left over. 4s into 25 go 6 with 1 left over. 4s into 16 go 4 times. So I'm going to have 4a, 64a cubed take away 1 is equal to 0. So solving this equation, guys, so let's delete this again now that we've actually worked out that bit. So solving this bracket equation, either 4a is equal to 0, so either 4a, okay, so either 4a is equal to 0 or 64a cubed take away 1 is equal to 0, okay? Oh, it should be a 0, guys, I apologise. There we go. Or 64a cubed take away 1 is equal to 0. Okay, so solving this, guys, okay, we get that a is equal to 0, so that's one of our real solutions. Or, and then solving this, guys, adding 1 to both sides, divided by 64, and then taking the square, cube root, sorry, we get that a is equal to 1/4, okay? When you rearrange that, okay, so adding 1 to both sides, I get 64a cubed is equal to 1, divide by 64, so I get a cubed is equal to 1/64, okay, so adding 1 to both sides, I get this, okay, divide by 64, and then we'll take the cube root, okay, because that's the opposite of cubing. The cube root of 1/64, guys, is equal to 1/4. But again, if you're not sure, then just use your calculator once you get to that stage. So a is going to equal to the cube root of this, guys, okay, which equals 1/4. Now I know many of you will be thinking, well, hang on a second, I've got a to the power of 4 here, so I should actually have 4 roots. But the question says find using algebra all the real roots. So these are all the possible real roots. So my guessing is that the other 2 roots will actually be imaginary, but for the purpose of obviously A-level maths here, we don't have to worry about complex roots, okay? So technically, yes, although it says 8 to the power of 4 here, and we should have 4 distinct solutions, okay, my guessing is that we have 2 real and then 2 imaginary, but we don't have to worry about any imaginary or complex roots, because the question explicitly says, work out all real solutions, okay? So these are my 2 real distinct solutions to this Quartic equation, okay? My guessing will be is that we'll have 2 other complex roots, but that's a lesson for like further mathematicians, okay, A-level further maths, okay, and I don't want you to obviously worry about that at this stage, okay? So that's question 1 done, guys, okay? So let's just delete this now, okay? So that was pretty tricky actually, yeah, for a 4-mark question. Okay, the next part I've got a Quartic equation. Okay, this time it's a bit easier because it's in like a form of like a quadratic. So I can do a bit of substitution to work out my values. Okay, so part I've got a Quartic here. Now, if I open up like a double bracket here, okay, if I think of it, the equation, okay, so if I think of it as b squared plus 7b minus 18 is 0, that might be a bit easier to actually visualize, and then we can deal with the powers in a second. So think about factorizing this quadratic. Okay, again, 2 numbers that add to make positive 7 and times to make minus 18. That will be 9 and 2. Okay, 9 and minus 2. So 9 times minus 2 is minus 18, and then 9 plus minus 2 gives us 7, guys. Okay, and again, if you're not sure how to factorize quadratics, then it's obviously worth revising that topic, okay? But again, on the calculators, I think it's the Casio EZ91991X or something. It has like a quadratic solver, so you can just plug it in, okay, to your to your Casio calculator to work out your solutions to the quadratic if you have those special calculators, okay? So, factorizing this, so it will be b plus 9 and b take away 2. Now, this is the solution, okay? This factorizes this quadratic. However, we have b to the power of 4 and a b squared. So all we just simply do is just bump up the power by 1. Okay, it goes to b squared. Because b squared times b squared equals b to the 4 using the laws of indices. I'm going to have minus 2b squared plus 9b squared, which goes to 7b squared, and then 9 times minus 2 makes minus 18. Okay, so because it's a Quartic there, I just bumped up the power by 1 to change it from a quadratic to a Quartic, okay? For that, okay? So this is the factorized version for this now, okay? Deleting this arrow here, because, yeah. So either b squared plus 9 is equal to 0, or b squared minus 2 equals 0. Okay, now hopefully you can recognize that the first bracket, obviously I don't have any real solutions for this, but the second bracket I can solve as normal, okay? So b squared take away 2 is equal to 0. Now solving the first equation, obviously I get complex roots because I get b is equal to plus or minus the square root, obviously negative 9, which obviously I can't have in mathematics. I can't take the square root of a negative number, okay? So it has no real roots there. However, it has real roots here, guys. So it has b is equal to plus or minus root 2. Okay, when you rearrange that equation. Okay, so in exact form, okay, we have that b is equal to minus root 2. Okay, and b is equal to positive root 2, guys. Okay. It's best in these scenarios to leave your exact answer in exact form. Okay, so examiners can clearly see where you're getting your answers from. Okay, because by rounding it, I think it will cause a bit of problems in your exam. Okay, so where possible, leave your answers in exact form, guys. Okay, now again, just to obviously be clear, guys, although it is a quartic, and you might be thinking, hang on a second, it's meant to have 4 roots. Well, we actually have 2 imaginary roots here, which I don't want you to actually worry about for this stage, because that's a lesson for A-level further mathematicians that we'll cover in the future. Okay, but this is what I call like a complex root. Okay, if you're interested, the solution to this here would be b is equal to plus or minus 3i. Okay, but I am actually like diverting here actually and not actually answering the question. Okay, but if you're interested in like imaginary or complex roots, okay, we take I as the imaginary number to be the square root of -1. Okay, but that's like a lesson for like another day, yeah, and I don't want you to actually worry about that at this stage. Okay, at this stage, it's just obviously answering the exam question. Okay, so make sure that you read it very carefully. Okay, real solutions, the quadratic, okay, or the cubic or whatever, has to obviously be greater than or equal to 0 for the discriminant for me to have distinct real solutions or a solution. Okay, I can't solve this one, okay, for part II, but I can solve this quadratic, okay, because obviously plus root 2 and minus root 2 are real numbers, okay, what I call real solutions. Okay, right guys, that's the end of today's short video, okay, on question 2 on the May 2019 AS Pure Maths Edexcel paper. Okay, if you found it useful, please like, please comment, please share and subscribe, and I'll catch you all inside the next video. Okay, bye for now.